Yo, I hope you guys are well. It's been a while. Okay, so from Algebra 2 kids, we're going to talk about the learning task from today, using polynomial functions to model stuff. Okay, so here we're doing polynomial functions to represent volume. Okay, so pause the video and familiarize yourself with these questions on this slide, and then we're going to go over it. Okay, great. So here, part A is asking you to draw a diagram representing the scenario, okay, where X represents the side length of the corner squares. Okay, so here, what you're trying to do is you should first draw the rectangular piece of cardboard. So I did that here, and don't be overwhelmed with all this labeling, okay? But basically it's this blue outer piece, okay? And since you're cutting out square corners from each of the corners, and each of those corners have a side length of square corners have a side length of X, right? So all I'm doing is just labeling that here. X, 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 and then yeah, okay. And then it's telling you right here that the dimensions of this cardboard piece, the original piece, was 14 by 32 inches. So I just put that here. So this outer piece is 14 inches, and then this other piece is 32. Okay, and then what's going to happen is that after you cut up the corners, you are going to get this box. Okay, and once again, let me know if this is confusing, if just having all of the math done beforehand, because I know sometimes it could be overwhelming. If not, then I'll just go back to the other way and just do everything from scratch. But this also helps, yeah, makes it easier to explain a bit. Okay, but anyways, yeah. So after you cut the corners and you fold up the thing, you're gonna get this box. Once again, if it's hard to visualize, do some budget math. Okay, go get a rectangular piece of paper, right? And something like this, okay? And then cut out square corners and label them X, and then try folding it and then see what happens to the dimensions, okay? Where did those dimensions go? Okay, so here, like I said, this total piece here, I'm gonna call this vertical piece for length. Okay, so here the length is 14, and before cutting is 14, and here the width is 32. But after you cut this and fold it, pay attention to the colors. Okay, you are going to get this box, and the length of this box is not going to be it's not going to be 14. It's going to be this green thing. Okay, and this green thing is going to turn out to be 14 minus 2x. Okay, just think about it. It's total piece 14. You're deducting x right from this corner piece, and then you're deducting another x from this corner piece, and you got that 14 minus 2x, and this is also 14 minus 2x. Okay, and then similar reasoning to get the white piece, right? 32 minus x, 32 minus 2x, and then the height's going to end up being x, which is the side length here. Okay, and once again, if it's confusing, fold the paper up and you'll see. Okay, this side length doubles up as the height for the box. Cool. Okay, so after you get the box, notice that this is a rectangular prism. So then we can use the volume formula, right, for the rectangular prism, and we know that's length times width times height, right? Length times width times height of the box. Okay, and then based off of this color-coded diagram, we can find exactly what each of these things are. L is 14 minus 2x, width is this. Okay, so for part B, when it says use the diagram to create a function v of x that represents this, it's this. Okay, and it's convenient because this v of x is expressed in factored form, and you can find the roots in your own time. Okay, you can do that as an exercise, something. Okay, and then part C, it says to evaluate these numbers: v of 0, v of 7, v of 16. Okay, and that's just simply plugging 0, 7, 16 into this volume function. Okay, one by one. Okay, you're going to end up getting v of 0 to equal 0, because when you plug it in here, you're gonna get 14 minus 2 times 0, 32 minus 2 times 0. I don't know what those are, doesn't matter. But what's important is that this third factor, this is gonna be 0. So basically it's gonna be a number times 0. That's just gonna cancel to, it's just gonna end up going to 0, okay? And then it's similar for v of 7, right? But this one, the first factor, 14 minus 2x, is gonna turn to 0, and this stuff I don't care about, because this whole thing's gonna die because of that. It's gonna be 0, same thing, v of 16. Okay, the second term, 32 minus 2x is gonna turn to 0, and yeah, okay? What does it suggest about the volume, and why does this make sense? Well, you should think about it a little on your own, but let me give you the first one. This is saying that when you cut a corner square with side length 0, the volume of this supposed box, it's misleading in my picture, but the volume of this box is going to be 0. And that makes sense, because think about it. If you don't cut anything, right, because it's side length 0, how on earth are you going to fold the net, this thing? There is going to be no height, so there is no box, okay? Similar reasoning for these other two. You should think about these cases. Cool? And then write in the comments or report back in class and all that good stuff. Cool? All right, and then part D says to re-express your answer, so the volume function, but in standard form. Okay, and then recall, we said the standard form for a polynomial, right? It's basically you are going to expand this by distributive property, right? By distributing these terms. So here you would do FOIL, and then after you get an answer for that, you're gonna distribute this x term into the inside. It's gonna turn to a trinomial. Okay, but yeah. Okay, and then after you do that, rewrite the expression from in descending powers from highest to lowest, left to right. Cool. So the work was done in class, period 2. Shout out to you. Okay. So here, like I said, wait. Okay, so you're gonna distribute this 14 to this 32, then this negative 2x, and then this. Okay. So you're doing this first. Okay. You're gonna end up getting this thing in pink. After, you are going to distribute this x in here. Okay, and if everything goes well, you should get this thing: 448x minus 28x squared minus 64x squared plus 4x cubed, right? But to make it in standard form, you got to rewrite it so that it's descending powers from left to right. So we're gonna do that like so. Oh, sorry. Before this, we combined like terms, so the inner two terms. Okay, x squared like terms, negative 2x. Okay, and then we can do. So this is a trinomial that I was talking about earlier. Okay, and then we can rewrite it. So then this is going to be it. All right, and then since my handwriting is quite crappy, I'll just read it. Okay, so it's 4x cubed minus 92x squared plus 448x. Okay, so that's another way of expressing your volume. Okay. Now, how do you know if you did this correctly? We can whip out Desmos and see. Okay, if everything was done correctly, if I put this into Desmos, and if I put this into Desmos, the graphs should be indistinguishable. In other words, they'll be the same graph. In other words, the graphs will coincide. Okay, so let me do that, and I already did that for you here. So watch. This was the original v of x. You put it in, right? It's going to look, it's going to be a cubic polynomial, right? It might not look like it because of these numbers are very big, okay? But if you zoom in, you'll actually see it. Cool? Yeah, okay? And then this is the other polynomial that we had, right? I just didn't write in standard form, but it's going to be the same. Okay, you could write it in standard form here. You're going to see it's going to be the same. But here, now I'm going to present it. You see that? The graphs coincide, meaning that they're the same. Cool. Some other takeaways from this learning task. You're not going to need all parts of this polynomial, okay? Because of the context, some values for x will not make any sense. In other words, you're restricting the domain, Okay. I want you guys to think about like which x values does this not make sense for? Okay. And think about it. Okay. It's a nice exercise. Okay. And yeah. And then also like what y values. Okay. Hint, hint. Look below here. Okay. Hopefully that was okay of an explanation. Once again, if the diagram was overwhelming because I already had the stuff pre-drawn, let me know. Any questions, just let me know. Okay. All right, guys. I'll see you tomorrow. And yeah, be good. Bye-bye.